Dear students, today we are going to learn about a new device which is known as telescope. You see, telescope is a device which is used to view the distant objects, and it is of two types. One which is used to look the celestial bodies, that is astronomical telescope, and another is which is used to look the earthly bodies, means trees, hills, distant objects, sea, etc., icebergs, etc. So anything lying on earth's surface that used for viewing such things are known as terrestrial telescope. The main difference between these two is that in the astronomical telescope we have inverted image, and which is not troubling us because celestial bodies are usually spherical and symmetrical. But if we need to view the earthly bodies, we prefer to have the erect image of the same body, and therefore slightly it is different from that of the astronomical telescope. Now, telescope can be also classified in the terms of reflecting surface or refracting surface. If a telescope is using the lenses, means refraction takes place to collect the rays coming from distant objects, that is known as refracting type telescope, which is very commonly used. And if we use spherical mirrors to collect the rays coming from distant object and produce their images, then that type of telescope is known as reflecting type telescope. Now we haven't mentioned over here, but refracting type telescope can be further divided into two types. One is Newtonian telescope and another is Cassegrain telescope. So now let us start of talking about the astronomical telescope. Now in the astronomical telescope we can have yet two type of arrangement. One in which the image of the celestial body is formed at infinity, which is called normal adjustment, and in another case we can have the image of distant celestial bodies, say star, planets, etc. The image of such bodies formed at least distance of distinct vision. So now we are at this moment we are discussing the telescope with normal adjustment, means the final image is formed at infinity. For this telescope we are having two coaxially held convex lenses. One is called objective and another is called eyepiece. Contrary to that in case of compound microscope, here we are using objective having greater aperture and greater focal length, and eyepiece having a smaller aperture and a smaller focal length. As you can see in the figure here, why we are having objective of large aperture, you can very well understand by the fact that the distant objects are so far that the light coming from them are very feeble. To make the image much bright and clear, we need to collect large number of light rays, and therefore we have larger aperture of the objective. While in case of compound microscope, the object is very close and we want greater magnification because the object is very small, and for to make up the shortage of light coming from the tiny objects in case of compound microscope, we can have additional source of light employed on the object, thrown on the object, or thrown on the species or virus or whatsoever tiny object we are viewing, so that the less number of light received by a smaller aperture of the objective in case of compound microscope can be compensated by putting extra brightness on the virus or on the tiny object. So here we are having, in case of telescope, we are having objective of larger aperture and eyepiece of a smaller aperture. Now we consider that the object is far away and therefore rays coming from the object could be taken as parallel rays. On passing through the objective lens, they will converge at focus of the objective. Now we adjust the position of eyepiece such that the focus of eyepiece coincides with the focus of objective lens, so that the image A1B1, which is formed by the objective of the distant object at point A1B1, this image, which is real and inverted, acts as the object for the eyepiece. And since the focus of eyepiece is coinciding with the focus of objective, therefore the image of this A1B1 will be formed at infinity. So when seen, the image will be seen to be formed at infinity. Now we want to find the magnification of this device. We all know that magnification is, in this case, you see, magnification is ratio of angle subtended by distant object on our eyes to the angle subtended on our eyes by the image. Now you can see, if alpha is the angle made by parallel rays coming from infinity from that object, then certainly the ray which is passing through the optical center of the objective will pass undeviated and reach the eyepiece, which means that the vertically opposite angles must be equal, and A1B1 divided by OB1 will give us the value tan alpha. Alpha is the angle subtended by object on our eyes, and this is angle beta, which is the angle subtended by the final image on our eyes. Now value of beta can be found by taking the tan value of beta, as we have found the value of alpha. Taking the tan value of alpha, we have considered that angle alpha and beta are small, so that can be beta can be nearly equal to tan beta and alpha can be nearly equal to tan alpha. Now this here you see, one thing you have to bear in your mind, that any ray which passes through the optical center passes undeviated. So if we consider some ray coming from point A1 and passing through the optical center of eyepiece, then it should pass undeviated. And certainly other rays which are coming from A1 and passing through the lens after bending in particular direction must be along the same direction along which the ray A1E should be. because while ray passing through optical center will remain undeviated, but other rays will be bending and all should be parallel. Therefore we can take this angle A1EB1 to be equal to beta, that is the angle made by the image on the object. Here image is formed at infinity, but this image will make the same angle on our eyes what A1B1 is making on our eyes when at a distance EB1 from the eye. And therefore we can write tan beta equal to, this angle is equal to beta, tan beta is equal to A1B1 divided by EB1. And so we have tan beta by tan alpha, beta by alpha is nearly equal to tan beta by tan alpha equal to A1B1 by EB1, A1B1 by EB1 divided by tan alpha, that and tan alpha is A1B1 divided by OB1, and A1B1 cancel out, it becomes OB1 by EB1. Now if we use the sign convention, apply sign convention, we see that OB1 is nothing but the focal length of the objective, and that is positive. Now we have the value EB1. EB1 is the focal length of the eyepiece. Now it is in this case what you see is we need to take negative sign because we are measuring this distance against the incident ray. Here you see A1B1 acts as the object. A1B1 acts as the object for this lens eyepiece, and we are measuring this distance against the incident ray, and therefore it is taken as negative, and so we get magnification is equal to FO plus FO by minus FE, and finally we can write it as minus FO by FE. FO is the focal length of objective and FE is the focal length of the eyepiece. So I hope you have enjoyed it. Now one thing we must also consider, that magnification is, now we can see, is directly proportional to the focal length of the objective. Means greater is the focal length of the objective, greater will be the magnification achieved. It means that greater will be the size of the telescope, and so while you visit some tourist places where you find the telescopes for fun viewing, you will see that greater is the range of the telescope, longer will be the length of the telescope. And therefore if someone wanted to have some comfortable telescopes, they use the prism to have the length of the telescope reduced due to the total internal reflection suffered by light within the prism. We have already discussed applications of prism, so that it becomes the length of the effective length of the telescope, even having the higher magnification, may not be as long by using the prisms. Now second thing is magnification is inversely proportional to the focal length of the eyepiece. So that means smaller is the focal length of the eyepiece, greater will be the magnification. So that's all for today. Thank you and have a nice day.